Hi everyone. In today's class, we'll look at something called colligative properties. Colligative properties are basically physical properties of a mixture. Okay. Now, this mixture kind of depends on what's being dissolved and how much is being dissolved in a pure liquid, like water. So we'll look at what kind of effect adding dissolved substances to a pure liquid, such as water, um, we're generally going to focus on two physical properties here, and that's freezing point and boiling point. So in terms of colligative properties, the first one that we'll look at is called boiling point, elevation. Okay, so elevation means to rise. So we're talking about adding something into water to make water boil at a higher temperature. So, example, we know that water under regular conditions has to be heated to 100 degrees. Okay, so water boils normally at 100 degrees Celsius. But if we just add salt to have salt water, salt water doesn't boil at 100 degrees. Okay, salt water is a mixture. So depending on how much salt, salt water might boil at a temperature greater than 100 degrees Celsius. Okay, and that is known as a colligative property. So when a substance's boiling point temperature changes because you've dissolved something into that liquid, you have altered its physical property. And that property is called a colligative property. Okay, so let's just look at what's going on at a molecular level. So if we drew a glass of water, and I'm going to keep it fairly simple. Okay, so I have these blue molecules here that represent water molecules. Okay. And if I were to heat it up, okay, once the temperature reaches 100 degrees Celsius, these molecules of water can start rising up and turning into steam. So these are gas molecules of water. Okay. So by heating it to 100, I provide it with enough energy to enter the gas phase. Okay, it's not exactly as simple as that, but for now, we're going to keep it as simple as that. So once we reach 100 degrees Celsius, water molecules have enough energy to become a gas. aka boiling. So that's normal. Let's look at what happens if you add something like salt. It doesn't even matter if it's salt or if it's sugar, as long as it's something that dissolves in water. So again, we have our water molecules, but this time I'm going to add in some salt molecules. Okay, so what we tend to find is, say these are salt molecules. Okay, we tend to find that when we add salt molecules, water molecules tend to interact with these salt molecules. So they kind of get surrounded by water molecules like this. Okay, so now when we heat up water, it's not just water, it's water plus salt. So it's not a pure substance anymore, it's a mixture. So what tends to happen is, in order for the water molecules to separate and start entering the gas phase, you have to give it a bit more energy, okay? Because the particles that are interacting with the salt molecules, okay, they're not going to be easily let go and turn from a liquid to steam. Okay, so you still have boiling happening. Okay, and it's only the water molecules that are boiling. But because the salt molecules kind of interfere with this process, the temperature that you have to heat it to has to be higher than 100 degrees. So the boiling point has to be greater than 100 degrees Celsius. Okay, and it often depends on how much dissolved substance is present. Okay, so let's get some of this in writing first. In order for water to boil, more energy is needed to overcome the effects of adding a dissolved substance. Therefore, boiling point is elevated or increased. Okay. So when people put salt in water for cooking, okay, it's not necessarily just for flavor. Sometimes they're just trying to make the water hotter than normal. Okay, so example, when cooking, adding salt to water causes water to be at a higher temperature. Than 100 degrees Celsius. Okay, but keep in mind, it doesn't have to be salt. When people put sugar in water and they try to boil it, the same thing happens. Okay, so it doesn't matter what's dissolved. Okay, just how much. Okay, so typically if I put in a few tablespoons of salt, okay, in water, I can get it to boil at 101 degrees Celsius, maybe 102. It all really just depends. But usually there is a limit to how much you can put in, because once you start putting in a lot more salt than water, then it's basically going to be more salt than water. And in order for something to turn into a liquid, now you have to raise the temperature to melt salt. Okay, salt has to turn to liquid and then turn into a gas, right? You no longer really have salt water anymore. So there is usually some kind of limit in terms of how high we can increase the boiling point of water to just by adding a dissolved substance. Okay, so that's called boiling point elevation. The second colligative property is called freezing point depression. Okay, freezing point depression means that you're lowering the freezing point. Okay, the freezing point's not becoming sad or anything. Okay, you're just changing it from what it would be. Okay, if it was a pure substance. Okay, so again, we can still use our example of water plus salt. Okay, because again, it's a mixture where salt is dissolved in water, where a solid is dissolved in a pure liquid. So we can all agree that the freezing point of water is normally at 0 degrees Celsius. Okay, but by adding salt, water will freeze at a temperature less than 0 degrees Celsius. Okay, that's the colligative property. Okay, depending on how much salt we add in, we can lower the freezing point of the substance. Okay, so that it freezes at a freezing point less than the pure substance would. So when you think about this, this is happening right now. As the temperature starts to drop below zero or around zero, okay, water will freeze, right? So last week when we had, let's say, a lot of snow, okay, as snow starts to fall, they generally start to melt. So the city might decide to put some salt onto the roads. That's not for traction, okay, and it's not to help prevent things from slipping and sliding. If they just want to do that, they could just add sand. But if they add salt, salt generally keeps the freezing point now of water till below 0 degrees Celsius. So it has to get much colder than 0 degrees Celsius in order for that water to freeze. Okay, and in effect, that does help prevent some slippery situations. So if the temperature outside remains at zero, most of the ice and snow won't actually be solid. Okay, it would stay as a liquid. So in winter, adding salt will decrease the freezing point to less than 0 degrees Celsius to prevent water from freezing too early. Water, well, at least the water mixture, so let's say water mixture, can only freeze at lower temperatures now. And we're talking about maybe, let's say, -2 to -5 degrees Celsius instead of 0. But that gives us enough time to be able to adjust for these winter conditions and to make the roads less slippery, okay, if the temperature has to fall a few degrees below 0. So all in all, these are two examples of colligative properties. So to summarize, colligative properties are based on how much dissolvable substance is present in a mixture with a pure liquid. The type of material, or the type of dissolvable material, have no influence. Okay. So whether you use salt, use water, salt in water or sugar in water, okay, anything that dissolves in a liquid, that will now affect its colligative property. And colligative property comes in at least two types. One, boiling point elevation, and two, freezing point depression. That's all I have for today. Thank you very much, and see you next time.